Hello, I'm Trista Sears. This video will cover cognitive load theory, its implications for instructional design, and its effects. Cognitive load theory grew out of the research on working memory completed by Sweller and other educational researchers in the late 1980s and early 1990s. This theory proposes that as learners, our working memories are incredibly limited, and once this capacity is exceeded, our ability to learn can be negatively impacted. Cognitive load theory views learning as a process that involves three memory structures: working memory, long term memory, and schemas. These memory structures can be impacted by three load conditions: intrinsic, extraneous, and germane. These load conditions can work together in a cumulative fashion to exceed the capacity of our working memories. It is important for instructional designers to be mindful of cognitive load theory and its impact on learning when we are designing learning experiences. As designers, it should be our goal to reduce cognitive load where we can. Well thought out designs can help to reduce both intrinsic and extraneous cognitive load, freeing up cognitive resources for germane cognitive load, also known as the learning process. The effects of cognitive load theory occur at the intersection of the learning process with the information that we are learning. When instructional design based on cognitive load theory was compared to conventional designs, research demonstrated many effects of the cognitive load theory. Let's look at two of these effects: the worked example effect and the split attention effect. Sweller describes the worked example effect as occurring when learners who are provided with a worked out example prior to a test perform better on the test than learners who were only given problems to solve prior to the test. This effect occurs because there is a reduction in both intrinsic and extraneous cognitive load. We are reducing intrinsic cognitive load by reducing the complexity of the information to be learned by providing the worked out example. And we are reducing extraneous cognitive load by providing the cognitive framework for problem solving. This is an example of a worked example. This is the type of instruction that would be provided to learners prior to asking them to complete a problem that involves finding the perimeter of an object. Sweller describes the split attention effect as occurring when learners need to consider information from different sources at the same time. If the information is separate and the learner has to hold information in their working memories to locate the next piece of information, then cognitive load is increased. The split attention effect indicates that if the information can be pulled together in a cohesive fashion, then both intrinsic and extraneous cognitive load can be reduced. Intrinsic load is reduced because we are decreasing the complexity or element interactivity. We are also reducing extraneous cognitive load by presenting the information all in one place, reducing the need for learners to search for the next nugget of information that they need to continue learning. This is an example that would cause split attention. We can see that there is a diagram of a fish on slide 1 and the legend for the labels on slide 2. This causes the learner to need to flip between two different slides to get all of the information that they need to learn the parts of a fish. But when we label sections of a diagram on the diagram instead of in a legend, we are helping to reduce cognitive load by providing the learner with all of the information that they need to learn the parts of a fish in the same slide. This video provided you with a brief overview of cognitive load theory, its effects, and implications for instructional design. If you would like to explore any of these topics further, I would encourage you to look at some of the references that I used in creating this video. Thank you for watching.